Yes.
So, welcome to today's presentation, which is about the application which we built on Akka framework or toolkit. And it will be probably a bit untraditional for InDeEd, but I hope that it will uh, give you some information. So, to get on the same wave, we'll first touch the terminology. So, Akka is open source toolkit. They stress that it's not a framework but toolkit, so it doesn't force you to follow any architectural rules except of actors, and it is for building distributed, concurrent, fault-tolerant, scalable, responsive applications. Lots of strong words, but apparently it works. It's available for Scala and Java, and it uses actor pattern for as basic building block, which you will see. What is actor? There are two kinds of actors. One of them is quite uninteresting, which is the type actor. That's basically an interface class with implementation, and Akka is just wrapping that. Methods are called directly, and it's not much fun with them. But they are also not used that often. So our application is built on untyped actors, and for you to imagine, untyped actor extends untyped actor class, and it has to implement onReceive method, which is like basic entry for the actor, where it receives messages from other actors. If that actor has some dependencies, they are either injected via constructor, or actors can also create other actors and supervise them as its children. We started with the flat structure, but in one case, we also are using child actors. So these are just pieces from code so that you can see how actors are created. It looks complex, but it's quite simple. So this system is from Akka, and we are asking it to create actor with some properties and with some name. The name could be, of course, here as a string, but we have it in each actor. And the properties also could be outside, but again, we have them inside actor to keep the stuff together. These are dependencies of the actor. So they have to be created like before, and also there is some support for dependency injection systems, but we are not using that. And the second snippet just shows the way how actors talk with each other. So there's method tell. You supply a message. Messages are untyped, so they come just as an object, which you can see in previous slide. So there is just object message. So inside that method, actor has to decide what kind of message it is and what to do with it. And also, the second argument is a sender of the message. So usually there will be like self, which is pointing to the sending actor. And this pattern is quite interesting because actors can talk to each other like in, for example, theater. So it's good for imagination of some abstraction. And this is the only like piece of code in the presentation. So I'm showing it for illustration. So just briefly, here are some the name, the properties for the creation of the outlet of the actor. Then there is a constructor, which is in fact called by Akka. There are some internal structures and dependency fields, and you can see how the onReceive method looks like. So usually when you're in Java and somewhere the instance of is used, then it kind of smells, but because the messages here are untyped, there is no other way. This is by the way, I forgot the name of the library, but it's using some libraries for Scala-like approach. But inside this match of is really instance of. So this says when I receive message of this type, then do this. When I receive this type, then do that. You can see here that in case of outlet, it's just forwarding the message to another outlet, another actor, and another processing for another type of message. And here is the second part of the actor. So these are like methods processing different types of messages, and they do stuff and they talk to other actors, and basically that's how Akka works. So it's a network of actors which talk to each other and they do stuff.
So Peter, contact mapper and this other mapper are other actors, right?
Yeah. So contact mapper and outlet mapper are other actors. You can recognize them by type actorref, and they are injected by Akka through constructor, and that basically defines to which actors this actor can talk. There is some exception, but we will get to it. So before we take a look at the application structure, some business background. So the application is consuming RabbitMQ view, and as a result, it's transferring data from one system to another. And there are two key business objects, which is outlet representing media outlet. So some company who prints newspapers or publishes internet newspapers. And then there is journalist, no need to say more. And what is interesting and source of issues in Gorkana database, employee is just a relation between journalist and outlet. But in the source system, some information which Gorkana has stored on journalist is stored on employee, and basically we are not receiving journalist but employee records. Yeah, and another challenge is that they are not sending messages to Rabbit server which would say, like, this is creation, this is update, this is assignment of the journalist to outlet, but they are sending only basically two statuses, active and inactive. And it is up to us to kind of figure out which of these operation it really is. So we start the model, and now I will be showing the first how the model looked the first time it was put together. Yeah. So we have some queue processing actor which contains Rabbit client which talks to Rabbit server, and this actor just receives messages from Rabbit, and when it gets notification that the message got processed, it acknowledges back to Rabbit that the message got processed. Then there is the JSON mapping, and in this actor, we create RDS POJO out of JSON message which we got from the previous actor. Then there are two other actors, which here the processing is already split to journalists and outlets, or contacts and outlets. And in these two actors, there are most business rules and mapping rules which decide whether the message is okay and whether that business object is okay and whether it is allowed to go on. And finally, two endpoint actors which communicate with some REST API of the target system, and which initially they covered just create or update operations. These uh, lines indicate that, in fact, for outlet and contact mapping to decide whether the incoming message is a creation or update of business object, it has to talk to REST API as well to get the cross-reference. So it takes RDS ID and asks for module ID. If it doesn't get any, then it's create operation, otherwise it's update. But these calls are like just helper calls, so they are not anything special in the actors system. They are just some services. More lines. Each message has to be processed, and there has to be some ruling about or some information about how the message got processed. And by processing, it means that it can be also discarded because of some business rule, but that's still processed message. So these lines are indicating some kind of feedback to queue processing actor, and each actor which contains some business logic which could lead to either discarding or further processing of the message has this link back to queue processing, because that actor then needs to say to Rabbit that the message got processed, so that it can get like more messages. And if you were looking how actors are getting created, you would notice that if we wanted this queue processing actor to be injected in other actors, it would lead to circular dependency, because you cannot create queue processing actor without having JSON mapping, and that cannot be created without having these two and these two. So the original creators, which is Jirka Zmeškal and Boris, they used little trick. So the reference to queue processing actor is being passed on inside the messages which flow through the actors. So any actor, when decides that it needs to react with feedback to queue processing actor, can do so, and it can tell queue processing actor that the message got processed. So, but for clarity, we get rid of them and we get to next stage. Yeah, so this is how the network looked after sort of first try. And immediately there were obvious some issues. So, and Akka performance was to blame for both issues. One issue was here on the entrance. The queue processing actor was massively reading messages from Rabbit. So when they tested it with just a couple of messages, that was okay. But it turned out that the client is able to prefetch even several thousand of Rabbit messages before sending them further on, or well, maybe some messages were flowing, but here it was taking a lot of messages. So we had to limit the prefetch size to 50 messages, and that's maximum number of unacknowledged messages that the application is allowed to like pull from server. So the more messages are getting in only after queue processing actor confirms previous messages. And there was also issue on the other side because that API is used by other systems, and when we started this application and there were enough incoming messages, it was able to completely flood the REST API, so it became less responsive, and there are some collisions. So we decided to use one interesting feature of Akka, and that is specific dispatcher. Now here you can see actor creation like it was before, but this time it also calls with dispatcher and specific dispatcher. And in application configuration, this dispatcher is defined, and what we limited is number of threads and like minimum and maximum. And this throughput means that the thread processes at maximum 5 messages in one actor before the thread is returned to the pool for further use. And because this is the thread pool executor, and the default dispatcher is fork join executor with 24 threads for given machine. So those 24 threads were really stressing the API, and we use this API dispatcher only for actors which talk to API, so that it ensures that the API doesn't get overloaded. So after we started consuming of the messages, we bumped into another issue because of how incoming of how the system that feeds this rabbit, because how it works, it creates duplicate messages for contacts. So we decided to incorporate message deduplication into our system. Actually, it deduplicates only contacts because we didn't have issues with outlets; they are not duplicated. So this actor, when it receives outlet message, it just forwards it here. But for contact messages, it calculates MD5 hash of the message and it remembers the value for that given contact from previous message and can decide whether the message is duplicity or not. So again, this helped to reduce the load on the API because only relevant messages now were getting through.
By the way, contact is journalist.
Yeah, contact is generalized. Then we bumped into another issue, which was that the order of messages in Rabbit that were incoming into our system was not guaranteed. So we could receive contact information or journalist information before relevant outlet was existing. So we created like another actor when we encounter contact without existing outlet. We send it into this retry actor where it waits in some queue, and after configured time, it goes back to contact mapping actor where it makes another attempt to look up the outlet. Of course, there's some limit so that it doesn't cycle forever there. Let me check my notes. My mouse is playing tricks with me.
Quick notes. Peter was changing batteries before the presentation.
Yes, so another operation which we were sorting out was child outlet creation, because outlet can have child outlet, but the REST API doesn't support this operation as a whole. So it has to be decomposed into outlet creation and assignment to parent outlet, which so basically outlet endpoint creates the child outlet and then talks to self, which is also interesting method, and it assigns the child outlet to parent when it already exists. So that's kind of talking to self. Yeah, and in the next step, we decided that the outlet endpoint actor was doing too much. The code got like mixed, so we decided to create outlet routing actor so that it's like single entry point for messages and then separate actor for each operation. And when we did it for outlets, we did it also for contacts. We didn't need the routing because these two operations don't talk to each other, while here the create usually talks would need to talk to other. So when it receives message, and needs to talk to other actors, so it just replies to the sender, which is the routing actor, and then it can send the message to appropriate receiver. Also, we have implemented this delete outlet, but with star, because it's only for internal use for now. We are not processing the delete messages from here yet. So it's just for outlet child deletion. And next. So again, by running the system, we figured out that it is often happening that we receive two messages or multiple for contact, which are trying in the end to update the same record in database. And sometimes it's source of issues. So the REST call just fails. So to further improve the stability, we have introduced this message queuing actor. So after the duplication, the message goes into queuing. For outlets, it's just forwarded to this branch. But for journalists, it makes sure, this actor makes sure that for one RDS journalist ID, there is only one message in this branch. And when some actor here confirms processing of this message, and it goes here, the confirmation, then this queue processing also notifies this actor that journalist with this ID will processed, and that it's allowed to release another message if there is any message queued for that given journalist into the system.
So if you have a contact who got stuck in this outlet, right lookup retrieve, and now contact can be processed in the moment?
It can happen, but here it's just for few seconds because the time distance between outlet and contact messages cannot be technically longer. That would be some serious issue in incoming messages. And the next evolution step was contact deletion. So we created a new actor which goes through some business rules, and the issue with contact deletion was that, as you remember, me saying that they are in fact sending us the employees, then the deletion could be either removal of this employee from outlet, which would be like just removing of employee, not the deletion of the journalist itself. So it would be update operation, or if it's the last outlet to which the journalist is assigned, then it would be really the delete operation. So it's getting a bit more complex now, but only one more slide. So now we have implemented outlet deletion, but another catch is that when outlet gets deleted, then because of undefined order of incoming messages, we don't want to delete that outlet before we process all contact delete messages for which are related to that outlet. So we solve this by adding the outlet delete pending actor, which is creating for each outlet that is waiting to get deleted, we are creating separate actor. So this is the case when I was talking about that we are at one point using child actors. So this outlet delete pending is like manager of these actors. And we are also using a feature of Akka when you can set timeout for message reception. So when actor doesn't receive a message for given time, then it's some kind of event to which the actor can react to. So when we receive outlet deletion and it passes business rules, then it goes to routing and to the delete pending. And it creates actor with timeout. I think currently it's like 20 seconds. And now, if the timeout is triggered, then this actor tells the routing actor, now you can delete the outlet. But when we receive deletion for contact and it comes to outlet routing, then it through outlet delete pending, it resets the timeout. So we can say that the outlet gets deleted 20 seconds after we receive last contact delete message related to that outlet. So, and the final bit to evolution of this network, there was some requirement that based on some matching in this target system, we don't create journalists or outlets, but they go to some dashboard when the users can decide whether it's like creation of new object or whether they can match existing journalist from this database to ID in the incoming system, in data from incoming system, and so they like connect these two. So next time we receive a message for that ID, it automatically goes to updating of it. And since it's like interaction with user, we needed somehow to handle this. But because we need to enforce also the business rules and some additional logic, we would have to, if this was to be implemented on the side of this API, then we would have to duplicate a lot of code here. So we decided to create another entry point for the system. And this time it's like Gorkana Rabbit with its own entry point actor. And in the system, we had to switch off a couple of business rules so that they don't trigger, like some duplicity checks and so on. But relatively with simple addition, we were able to use the whole network of logic also for this feedback from users from the other application. And we are over time, but just 3 slides for the end. So, experience with testing. The network looked like really complicated, and also if you would like to cover like every possibility, then it would be a huge load of tests. So we kept unit tests for each actor separately, which tests the individual cases. And then we have integration tests for the whole network, where we only mock the queue processing actor and the endpoint services on the other side. And then we can verify that if we send this JSON into the system representing some outlet, for example, then if it's new for the system, that it really ends up calling create outlet and so on. And quite good thing is that Akka provides some test kit for our use Java test kit, which is useful for testing because it acts like an actor, and you can test that the actor has received some message and what kind of message, what's the content, and also from whom. So testing, we are creating the tests like as the network was evolving, and it was quite okay. It was following, in fact, the logic of Akka, so that was fine. Performance. At some points, the application was stopped, and so we had even, I think, 200,000 messages in the queue when we started the application again. And there are some business rules which discard the message really soon when it's found that it shouldn't continue to our system. So we were constantly able to process about 14 messages per second. Only some, of course, made it to the target system. And finally, only 20 minutes over time, recapitulation. Once you get used to actors pattern, That's important point. Then you will find the systems with Akka quite nice to read and easy to use. Of course, it matters how you name your actors. Uh, it, it, it has to be it has to have some logic so that the name really says what the actor does. Good functionality encapsulation, because when you look at actor and you find out that it's really doing many things, or when you are about to add some functionality to actor uh, and you're thinking, oh, this may not go here, or you just create new actor and put the functionality there. Flexibility, we have seen how the network has evolved from the beginning. Performance, I've mentioned. Multi-threading, that's something you get like out of the box. Simply Akka cares for this. And the last, testability. It provides some good means how to inspect what's happening, how which actor talks to each other. So it was good experience with this. So this is the final slide, and if you have any questions, if I roll back to
How do the actors listen to each other?
each actor has a message queue that is provided by Akka. So when you say, when actors says tell message to some actor, then Akka takes this message and puts it into the queue of that target actor. So the communication is one way. What is missing here is the types of messages which are flowing through the system, but it would only make it even less readable. So of course, there are different type of message that is coming through here, and that is, for example, coming through here. Like we have our types for these messages, and that's why also the recognition of messages according to type works good in our system, because we are simply not abusing one class for everything.
It means if you add consumer, you change the actor which send the message, right?
Yes, there is no common bus architecture. Just the actors, one actor talks to the other, and even the other actor has to look into the message, and there he can see who is the sender. But otherwise, the actor sees only, like, or usually talks only to its following actors in the network. There is, yeah, here it's like that the actor is actually replying to the caller, but in most cases it's just one way. So, if there are no more questions, thanks.
Thank you.